This is the fourth video, and in this video I'll take you through the species present with a strong base. So in this example you start with your strong base. A most common example is sodium hydroxide. With water it dissociates and you produce your sodium ions and your hydroxide ions. Now notice that in this reaction, it's actually a dissociation, so it's simply the sodium breaking up and it produces the hydroxides. We don't have a case of the hydrogen from water being transferred. So, like a strong acid, one of the most fundamental points to note is that the sodium hydroxide molecule, because it fully dissociates, is not present in the solution itself. It is fully dissociated, so you've got a lot of sodium ions and a lot of hydroxide ions. The other thing to note is because you produce the hydroxide ions through this dissociation, their concentration is much higher than the hydroniums. So when you go to place the species from highest to lowest, your first species, as always, is water at 55.6 moles, followed by your sodium ions, which are equal to the concentration of your hydroxide ions. Now, you would not get penalized if you put your hydroxides first and then your sodiums. The reason that they're equal is because for every sodium hydroxide that dissociates, it's a 1-to-1 ratio, so you produce 1 sodium, 1 hydroxide. What it does mean, though, is that because you're producing a lot of hydroxides in this reaction, their concentration will be much higher than the hydroniums. Let's look at the graphical representation. So there we go, water being on the left hand side, followed by the sodium and hydroxide bars, which are of equal height, which indicates that it's a 1-to-1 relationship when they dissociate, and those little hydroniums sitting there just to the right hand side. Because your hydroxide bar is considerably taller than your hydroniums, this indicates it's the alkali solution. Catch me in the next video where I'll explain weak acids.